Welcome to the Analytics Engineering Podcast, featuring conversations with practitioners inventing the future of analytics engineering. Welcome to the show. I'm Tristan Handy.
And I'm Julia Schottenstein. On this episode, we're going to hear from Venkataramani, who is the CEO of Rockset, a real-time indexing database for modern data applications. Before Rockset, Venkat was a director of engineering at Facebook, where he helped build real-time databases and where he ultimately drew inspiration from for Rockset. We'll learn about the trade-offs between different database architectures, why streaming and real-time databases have a role to play in the future, and what are examples of data apps that Rockset powers today. I'm really excited about data apps. For me, this is going to be the future of data. What do you think, Tristan?
This is a conversation that has been going on for at least a decade, probably long before I was even aware of it. But the advent of the modern data app has been overdetermined. I really think that we are at a point in time where data apps are going to come into their own. Technologies like Rockset are enabling the types of interactive user experiences that we would expect as users. But I think there's a lot of work left to do at the user experience layer.
Yeah, it feels like you can imagine the future, but we're often limited by our infrastructure. And also, in some ways, we are limited by our imagination. I love that you ask people what kind of database do they want, and they probably will answer something faster or more performant. But if you could think about how to redesign a real-time database from the ground up, maybe we can enable a whole different kind of future and really power data apps to take action in real time.
I agree. It was really interesting to get into Venkat's head over the course of this episode because it's clear that those who make databases don't actually know what people will build on top of them. It's kind of impossible for them to know. I have to imagine that you go back to Larry Ellison circa 1979, and he actually didn't know all the things that were going to be built on top of Oracle over the years too.
Yeah, Venkat is a guru when it comes to databases. I'm really excited for this episode and to hear what he has to say. Let's get into it.
Venkat, thanks for joining us. Really excited to have you on the program today.
Thank you. Thanks for having me.
Today, we're going to get pretty deep into some pretty nerdy topics. We kind of go all over the place, from building teams to in the softer side of data to today we're going to get pretty hard tech, I think. But before we go there, I want to talk about you as a human being before we talk about you as a professional. I'm just going to have a couple lightning round questions for you. Where'd you grow up?
I grew up in a small town called Trichy. Its full name is Tiruchirappalli, but it's in the state of Tamil Nadu in South India.
Yeah.
Yes, I don't know. It's one of the NIT colleges, which is a very reputed educational institution, is there. It's arguably the best one in the country. It's not the IITs, it's the NIT, right? It's usually ranked right after the IITs. And it was always my dream to go to school there because my dad went to school there. And while 25 years later I was there, and yeah, I grew up. It's right by the banks of a river with Kaveri, and there's a lot of farming and small-scale industry.
That's really neat. The early part of my career, I worked with several folks who spoke Tamil. And I don't know if you've had this experience before, but when you're used to hearing another language spoken, on a really consistent basis, and then all of a sudden, those people are not in your life anymore, you have, no access to those brain cells. I, really miss hearing the language spoken.
Growing up bilingual, I totally get it. I think even when I went to the college, that was the first time where I had to actually think and speak in English, because until then, because there, people from all over the country would be there. So literally I had a class of 48 people where we had 2 people from every state in the country. That's how, the classes are all assembled, because it's, very, very much merit based. So basically, there's no common language. Everybody's regional language is very different in India. When you have a class of 48 people where the only way to communicate with each other is in English. That was really the first time where I'd be in college and only be able to speak in English with everybody, and then come home and then with my parents and my friends and family, it was Tamil. And so it was that was my first experience. And then after that, I came to Wisconsin-Madison for my master's. And then, now I think I'm more naturally think and speak in English than, but the mother tongue is always there. I have extremely fond of that. Yeah.
Where's home today?
Palo Alto, Bay Area.
You're in the belly of the beast, where everybody else that makes databases lives.
That's true. Our office is also in San Mateo, which is I think like where the clouds, the data clouds are circling these days.
Right, exactly. What are you most excited to do coming out of a year of lockdown?
I think, a lot more like outdoor travel with the kids. Huge fan of the national park system. Love this country for having the vision to create that. If you come to our house one day, Tristan, you should. If you come to the Bay Area, we have a wall where it's like fully decorated with like national park posters and things like that.
Oh, neat.
So we're going on the Sequoia National Park, Kings Canyon, camping with the kids, for a week in the summer in the next month.
How old are the kids?
I have 2 boys, 9 and 10.
That's great. Last question, and kind of bridging into the world of the professional. You seem to have an unhealthy obsession with building databases. I don't know, high tolerance for pain. I don't know. How did...
Yeah, what is wrong with you?
How did this start? Did you happen into it, or was this intentional?
There was always a natural, like almost an intuitive attraction to, database is the one product that is almost implicitly a platform. After the operating system, it's a platform play, but you don't call it a platform, right? Literally, it's there to build all sorts of things on top of it. Database is also one of the hardest things to do in computer science. People could talk about, AI and ML and all of that. In order to build a good database, you can't just be good at, how processors work. You can't just be good at like how storage systems work. You can't just be good at distributed systems and like kind of consensus algorithms. It's really the it's really the confluence of, I think, all hard problems in computer science and systems problems in computer science. But I would say in hindsight, just kind of reflecting back on that, somebody joked and said, you've always been building databases in the most fun places, in that era, which is like early 2000s, it was Oracle. From mid 2005 to 2010s, it's Facebook's and the Googles of the world. That's where, I was managing online data at Facebook for about 8 years there. And then it's now in the cloud. And so literally I've just been, and before that it was just college projects where I was doing it. So I've been honestly, I think building databases all my life. So one reflection on this, like looking back and my, connecting that to my family and grow up. My family, my dad taught himself a harmonica, and he could play the harmonica. He's a painter. He paints like really, really well. He's also a professional, mechanical engineer and has his own business. But he has a very, he has the art bug. My elder brother could play, I think, like 17 different instruments. He's a musician. He's also has a professional eye, but he's an amazing musician. And I was the odd man out. I don't think I had a artsy. So I knew there were creative people. I think, long story short, I thought like building a database in a way to unleash creativity in the world, realizing that I'm not the most creative person in the world, but I want all the actual creative people that I know exist to be only bottlenecked on their creativity and not what can my data infra do for me, and wanting to build databases and just unleash creativity, because there's just so many amazing ideas people can dream of that I cannot, sitting in a corner. But if I can play a small role in unlocking that is extremely satisfying.
I'm not going to psychoanalyze you here and talk about your creativity. I'm sure that building databases takes a lot more creativity than you're giving it credit for. But you mentioned something that I want to give you an opportunity to talk just a little bit more about. You were at Facebook for 8 years. My guess is that they were 8 pretty interesting years. Most of us, myself very much included, have not had the opportunity to be in the belly of data processing systems at that scale. I'd just be interested to get you to share what it was like. Help us live in those shoes for a minute.
It was amazing. When I think about the 8 years from 2007 until 2015, when I left Facebook, they were hyper growth years. I think the user base grew from maybe 30-40 million monthly actives to 1.5 billion. If you think about it, it's only 50x growth. Engineering team, it was less than 100 people when the size of the people, like kind of building all sorts of, creative products, unleashing creativity and productivity and scaling how big the engineering team grew. It grew from maybe sub 100 to maybe 2,000, 2,500 engineers. The company was much larger. I'm just talking about the people that were, our internal customers, let's say, as an infra team. The infrastructure grew 1,000x. In terms of workloads, right? From few millions of requests per second, when I left Facebook in 2015, the online data infrastructure at Facebook was serving 5 billion queries a second. So it's literally a product of that first 2 numbers. So there is some math there, I'm telling you, which is the more engineers you hire, the more products you build, and then the more load it creates, and then your user growth compounds that. So I think that was the real essence of what we did. I think the fact that we were working on online data infra and people could just take it for granted, every new engineer could just take scale for granted, consistency for granted, and have extremely, good abstractions to be able to just imagine that as like just one giant database. They don't have to think about how distributed it is and how sharded and all these things. In extreme cases, they have to, but 9 out of 10 projects would be conceived and launched, and we wouldn't, the infra team wouldn't even know about it by the time, we were in like the early 2010s. So I think that is really what it was all about. I think the growth was insane. I think I quit Oracle and went to Facebook to learn, because things got too comfortable at Oracle and I wanted to make myself uncomfortable again and learn things that I thought I wouldn't learn at my previous job. And I have to say it was a good bargain. I think both on the technical side and also how to scale culture, how to scale teams. I think the learnings that came out of my experience there, I think I'm extremely grateful for, extremely thankful for.
A unique ride. I'm sure you had to go through it to really experience it. And I'm sure that there have been just so many, the alumni of that experience, I'm sure, have really such a tight network there.
Definitely. I always say this, people ask like in those 8 years, like what's a highlight? What's one thing that you remember and all that? I'll say even Twitter during scaling years and other, social networks that had gone through hyperscale, they had like these fail whale moments, there's always all these outages. And during those 8 years, which was like the most hardest years to scale with very little, resources in terms of both people, time and scarce resources. The thing that I think I'm most proud of is like during those 8 years, Facebook was pretty much working all the time. There wasn't really, what my team did there was necessary. Definitely far by, being sufficient for Facebook to be available. But that is really what I'm most proud of. Like, I think there was probably a 20-minute outage in that entire 8 years that I still remember that Thursday where I was standing. But that I think is probably the testament to the caliber of the team that I got to work with and the caliber of the technology that we built and the products that we built together.
I don't envy you. A Facebook outage must have been newsworthy. So I'm sure you remember exactly where you were during that moment. But yeah, we'll jump into it. We're going to talk a ton about databases today. You're our database expert, went to go study at Wisconsin databases. You're working on a startup now, Rockset, also focused on databases. Why don't we level set for our audience? Give us a sense for what are different options for databases out there. What are the differences between OLTP, OLAP, and what are you suggesting real-time databases offer that you can't get elsewhere?
I think databases, when they started, there was only transaction processing. I think the relational database invention of that and relational databases and SQL were actually two distinct inventions, and they were put together in one system. A lot of people don't know that history. It really they call it digital transformation. This was the true digital transformation on 1.0. Papers were replaced with records and computers. And that's why they're called even a record. It's really businesses. And the first killer app, and I still remember the stories that people used to say in Oracle. The first killer app was Oracle Forms. Think of that as Google Forms or SurveyMonkey that would automatically just give you a simple UI to CRUD on a record. And then all of a sudden, anybody can digitize anything. And once they can digitize something in a table, like nobody would want to do this. This is the genesis of how data was created, right? For the longest time, just accelerating that movement was the most important thing, just so that every record keeping actually happens, in a database. And then after a while, the volumes got really big and people wanted analytics. And so then there was a second category of databases that were created for just OLAP, just analytical processing. There used to be, the old name for this was DSS, decision support systems. And then what you're trying to do is really to try to go to a bimodal state where I do system of record, I do transactions in one system, I do ETL or some kind of like periodic movement, and I accumulate not just what the state of the database is right now, but I do this every night. Now I can do all sorts of analytics on sales, product, marketing, what's working, what's not. I think that is actually carried us way longer than what I think I would have imagined. I mean, DSS was the thing to work on, like OLAP was the thing to work on in the late 90s and early 2000. And then when I was in Wisconsin, what everybody was researching on streaming. Like the whole Wisconsin was about 20 years ahead of the time, in my opinion. The research was all about semi-structured data, except they picked XML. Wrong choice. XML is both hard for humans to parse and machines to parse. So, JSON clearly won the semi-structured thing. So people were actually researching on XML or semi-structured data and streaming. And this is what like PhDs were being worked on in the early 2000s. But it never really materialized until things like Mongo happened and Kafka happened. It took a long time. But so I really think for the longest time, we had transactional database systems that gave you speed, but scaling is extremely hard. Don't ask a transaction system to, do million transactions per second or hard analytical queries with like super complicated joins. Don't ask it to manage humongous volumes of data. Scaling is very, very hard. And then you got data warehouses and data lakes that are very good at scale. They're storage optimized, so you can throw a lot of data in it, but don't expect that to be application speed. You can get speed if you're rich, with a lot of cost and a lot of complexity, you can get, speed there, but it's usually prohibitively expensive to build an interactive real-time application there. And so now with the advent of Kafka, with the advent of semi-structured data becoming more and more norm and data flowing and the, we're in the information era now. There's, every year there's more information generated than all the previous years combined, right? And so in this day and age, I think it's time that the database world creates a third leg, which is what we call real-time databases. So this is you need speed and scale, but you're, from the speed side, you're willing to give up something. On the scale side, you're willing to give up something, right? And I'll tell you what that is. On the speed side, you're willing to give up transactions. You don't need locks. You're streaming data in real time into the system. You're not really doing read, modify, write, kind of like transaction processing here. That continues to happen on OLTP systems. But these are all large-scale applications. We're talking about tens and hundreds of terabytes of data, and you want interactive sub-second query processing, analytics on that. So the data never stops coming, the queries never stop coming, and I have a massive scale in terms of tens to hundreds of terabytes of data. Now, how am I going to build this application? So that is really this, and this used to be an exception, right? Like nobody really needed this 10 years ago because they couldn't even accumulate the data in real time. Now, with the advent and the proliferation of Kafka, every business in the world is acquiring their business data in real time, but they really can't put it to use because the only thing they do is they drain it back into a lake or a warehouse. And then everything is still slow. Right now, you're acquiring this, but why can't you put it to work? Because the third leg is missing. And the minute I want to build real time, and I also talk about this another dimension here, but I think that's kind of like, we can go into more details here, in depth, but I really think the whole database world is missing a third leg, and it's about time we think about it from as an entirely new category that we call real-time databases.
Yeah, so I have to ask, everyone's stuck debating, is it data lake or warehouse, lake house? What's the ultimate winner there? Are you suggesting neither? Is there some third state?
I think they're the same thing. The reason why data lakes were created in the first place was because databases sucked at unstructured and semi-structured data. And so they need a new name to just be able to throw. But databases have gotten very good at working with JSON data. Just pay attention, look around. Every database supports this reasonably well. And data lakes, usually would get away without really good SQL, right? And really good other data warehousey things. I think they're converging, whether you call, it's like, potato in every language, it's still a potato, it's like, it really almost feels like that. It's almost like, what data warehousing tech you want to kind of like assemble your, build your business around and build all your analytics around is really the question. And, I think certain use cases are better in certain platforms. Almost, I feel like the way the world has assembled is data lake seems to be more accessible to data scientists. And so there is a connection there in terms of not just, I just don't want to do SQL processing. I also want to do Apache Spark. Like I want to write very complex computation to do training and machine learning. So the data lakes seem to be more conducive for those kinds of workloads. But if you go talk to an analyst, they'd be like, give me SQL any day of the week. The productivity boost is just insanely high, right? Like if I have to write a Spark job every time I have to like generate a report, I don't want to write Python code or Java code. I just want to write SQL. I think they're converging, and I think there is a room for, based on the business and based on the kind of data you have and on what's important for your business. Is it data science the most important thing, or is it just data analytics that is very important for you? Depending on that, I think you should pick the one that serves your purpose better.
Let me play devil's advocate on the streaming topic for just a second. I don't know that I believe this myself, but most of the analytics engineers that I know don't actually care that much if the data is fresher than a day. Maybe there's some use cases where it would be great to have it in an hour or a couple of hours. But this may be a case of, this is just how the tech works today, and this is like what we have gotten used to. Of course, if you are a software engineer and you're building applications and you need a real-time database as a part of your application stack, 100%. I understand what you might build with that, but I'm curious if you see applications to the DBT, the analytics engineer workflow for real-time databases.
If you just think about, people will always want like faster horses and not automobiles.
Sure.
I think it's like, that's my best answer. But let's debug what you just said, right? If it is extremely complex to do real-time analytics, and even if the data comes to me earlier, there isn't really anything I can do about it. As a human, I'm not going to be checking this every minute.
Yep.
I'm going to look at this once a week. I don't need this to be fresher than that. This is where I think the world is. This is batch. This is why the minute you talk about real-time analytics, you will see they all become applications. They all get automated. At that point, once real-time analytics is possible without cost and complexity, your productivity goes up because you don't even have to look at it once a week and said, holy shit, like things have been complete, like, oh, since Tuesday, everything has been going haywire. All my ad spending have yielded zero. What am I doing? What would happen is if you actually go into the real time, future, in Tuesday, 5 minutes into that bad period, you'd get an alert saying, hey, something is off. You need to pay attention. Now, imagine the DevOps world living in batch, where you can't look at how your servers are doing. You can't get alerts. You don't get real-time monitoring. You can't do anything. You can't do their job. And so they are already in that era. They are already living in real time. No DevOps person will say, give me batch. And it's a one-way street. This is why I think once you get real-time analytics, it's not just, this is what I mean by acquisition. It's not just enough to acquire data in real time. You have to unlock analytics, sub-second analytics, interactive analytics. This is why Rockset, we spent a lot of time figuring out how do we index data in real time, because what's the point of accumulating data in real time, but every query takes 20 minutes? Well, you might as well just batch it at that point, But if my queries come back in sub-second and my data is coming in real time and everything is fresh, then I can automate so many things that I do, and it yields so much more productivity boost. And it's not like, oh, all these analysts will not have nothing to do. No, actually, they'll be working on the findings. They will be reacting to what's actually happening to their business and spend more time on growing their business, growing their revenue, growing their user base, and what actually matters for the company, as opposed to, waiting for your warehouse to return your report 20 minutes, 40 minutes later. There will always be a place for strategic kind of reports over a long period of time. There will always be a need for batch analytics. But for every use case that is doing in batch, there are 10 new use cases in real-time analytics, which will probably be a real-time application where you don't even think about it as real-time analytics.
You named one good application, thinking about metrics, you need it real time because you're going to take action. What are some of the other applications that people are building on top of Rockset?
Oh, so many, right? Logistics, supply chain. One of our favorite customers is doing the supply chain platform for heavy construction, and they track basically concrete trucks moving around. If it's not real time, it's not useful for them. If it's not accurate, you might as well not give me that report. There are hundreds of millions of these tickets driving around to construction, and they are automating a lot of that, right? Like they're automating the reporting, they're all automating even search on that in real time. If you basically take on the operational analytics, there's marketing automation. Everybody says, here's my marketing budget today. I have 50, 60 different campaigns. Which one is working really, really well? I want to double down on that right now. And it's not a strategic decision I'm making whether I should have more Facebook ads or Google ads or what have you, or the CMO is making that kind of a decision on a weekly or monthly basis. This is like on the day, which campaigns do I run? Security operations, don't tell me I got hacked 3 days ago. I need to know right now, right? Risk operations, think about what happened with GameStop and hedge funds. If you're not managing a risk in real time, by the end of the week, your company might not be around, right? And so there is customer support operations. So I think there is a lots and lots of business operations can actually be very, very effective if they know how to respond to real-time data. Now, when they don't have it, right now, all of their processes are around having partial data and just executing on a plan blindly and then seeing, okay, did we do the right thing? And then kind of like realigning once a week, once a month, once a quarter. I think it will basically happen a lot more, in real time when, in my opinion, like everybody becomes an analyst, but they're not even thinking that they're doing analytics. It just basically will become the new norm that, every business has visibility into what's happening every minute of the day.
I have to assume some of these applications that you're talking about are being built today, but they're probably being built using something else. Like what were people doing just prior to finding out that Rockset even existed? What did it look like?
Oh, yeah. Basically, do you know what a Rube Goldberg machine is?
Yep.
So that's exactly what it looks like. I mean, exactly what were people doing before DBT? I think people were building ad hoc.
Yeah.
I would call it also another version of a Rube Goldberg machine, right?
Yeah,
It's just
yeah.
scripts calling scripts and...
It was a folder on your hard drive that had a bunch of .SQL files in it.
Yes, and how do I share it? How do I test it? How do I collaborate on this? Forget about it. So I think there is just tremendous amount of complexity. Everybody's duct taping multiple disparate systems that were never tested together, that were never built to work with each other. And this is why, one of our customers that came and said, like, why are you using Rockset? Somebody interviewed them, not us. And then we got that and said, Rockset took our 6-month roadmap and shrunk it to a single afternoon. So in their head, this is what's happening, which is, oh my God, I got to build a Rube Goldberg machine. I have my data here in like DynamoDB. I have to somehow find a way to replicate this in real time. I need like the whole thing around some event bus, Event Bridge, AWS Event Bridge or what have you. And I have to subscribe this. I write another consumer and load it into like Elasticsearch or maybe Postgres, maybe a combination of these. And then I'll send some queries this way and some queries that way. None of them give you SQL. None of them give you joins. Everything is just like a horrible mess, right? And you can do that for one real-time reporting project. What happens, you turn around and somebody asks for one more and you're like, I need a bigger team. I can't do this. And so the other problem with Rube Goldberg machines are you can't iterate on them. Once you build them, you have to maintain them forever. The operational complexity is just insane, right? Nobody, friends won't give that kind of work to friends. So really, I think what Rockset really leverages is the cloud, really. I think, we can actually provide a turnkey real-time analytics solution born in the cloud. Rockset cannot run on-prem. It has dependencies on S3. It has dependencies on all the cloud infrastructure and systems where we can elastically scale our compute up and down based on your workloads and things like that. None of that would have been possible on-prem. And so this is why I think that's where our simplicity comes from, really embracing the cloud 100%. So beyond just speed and scale, I think simplicity is the third vector. And very thankful for the advent of public clouds and obviously huge fans of what Amazon, Microsoft, Google are doing, and very, very happy, that we are able to stand on the shoulders of those giants to be able to provide a world-class real-time analytics solutions in the cloud for our customers.
So it sounds like what you've been able to do is really operationalize real-time analytics, but it also feels like you get a little bit of the best of both worlds with Rockset. Often when there's like a new technological innovation, it feels almost like magic. But underneath the hood, there's something working to solve this problem. It sounds like it's indexes. Tell me a little bit more about the secret sauce of Rockset and underneath the hood, what's going on.
This goes back to our realization that, for real-time analytics to really become a thing, it's not just you're right optimized in terms of like, you can, really quickly accumulate data in real time and do 1 million writes per second. But all queries are, still run like a warehouse. Then, a warehouse is good enough to be able to do that. You don't need another one. And so, we really looked at what did Facebook do to make its newsfeed real time? What did Google do to make their search indexes real time? And, all these these kind of systems, if you look at their storage architecture, real-time indexing is key, right? Like they are able to continuously get new data, index it before they're storing it, and basically have a massively scalable real-time indexing system. So if you look at kind of like Rockset's storage architecture, it resembles a distributed search engine a lot more closely than a distributed database, right? And we call it converged indexing because we can't just build a real-time indexing, but we also needed to build a query engine on top of that, a SQL query engine on top of that. And so if you look at our compute engine, that will look like a distributed SQL database, right? Like it basically knows how to do joins scalably. And we have a distributed SQL engine that you submit a query, it breaks it down into fragments, hundreds of fragments, sometimes several thousand fragments. Within 1 millisecond, they get scheduled on your entire distributed system that is basically storing all of your data. In batch-based systems, they can take their time. Usually it takes multiple seconds. In Rockset, it takes 1.2 milliseconds. And instantly your query is starting to run as fast as it can on all of that hardware. Again, if you look behind the scenes on what's happening when you type a Google search, that's exactly what's happening. Your search goes through and gets very, very quickly, efficiently distributed to a massive distributed system. And then the queries, the results come back as quickly as possible. So it's really this combination of both the storage system looking like a search engine and the compute system looking like a SQL engine coming together. Both of them have had lots of they've developed a lot, right? Like search engines and like the whole understanding of it matured really, really well, right? Like even Google actually initially had to rebuild their whole search index every so often, every hour or every day or whatever. That's what Google looked like in the early 2000s. People don't remember that. Google went from batch to real time. Facebook newsfeed's first version was batch. They would do ETL jobs on everybody's activity, accumulate all the data, build a newsfeed.
That is so funny.
Yeah, build a newsfeed for everybody and then say, hey, here is your newsfeed, and won't refresh. Now, can you imagine the world where Google search or Facebook newsfeed is not real time? So this is a one-way street. The world is going to go there. And you won't remember, wait, people did that? And this was not even that long ago. People have even already forgotten because they take real time for granted. So coming back, what is the real crux? So we are really taking the best of what search engine technologies and advancements have happened to make real-time indexing at scale work. But that alone is not sufficient, because real-time indexing just allows you to retrieve the data that is coming in real time very, very quickly. But there is still a lot of SQL processing you need to do. You need to be able to join data, aggregate data, sort data, window functions and other very complex analytics that you want to be able to do. So we also built in C++, like modern, again, born in the cloud, massively scalable distributed SQL engine. And they are tightly integrated with each other. The SQL engine really understands the way the data is indexed. And so it knows for a given query what indexes to exploit and how would be, what would be the fastest way to get the response. And so the combination of that is what I think is very unique about Rockset. There's a few algorithms that we have invented along the way, but if you really look at it, it's almost like electric cars. The car chases dashboards. I mean, people are innovating that, like, Tesla didn't invent that. Battery technologies have gotten better, in electrical, energy management. It's really suddenly you put them together and suddenly you have the fastest car in the world, that has no drag and, accelerates like very, very quickly. So it's almost like that. These two technologies always existed. For some reason, they were never fused together to build a distributed system. Maybe there was no need. Maybe there was really not needed, up until real-time analytics, that the world needed, the market needed this. And now I think it's time that, systems like this converge these disparate, these two category of systems to be able to provide real-time analytics. Because in real-time analytics, a lot of people talk about data freshness. The word real-time only evokes data freshness, but fast queries, without subsequent fast queries, you really can't give people real-time analytics. So you need fast queries on fresh data, not just fresh data. And that's why I think we had to innovate both on indexing in the storage tier and also build a distributed SQL engine on top.
Hey everyone, just dropping in to let you know that the annual Analytics Engineering Conference, Coalesce, is back. We had the first Coalesce last year in December, and it was fantastic. We had 3,000 registrants, tons of presentations, and this year is going to be even bigger. Register for free at coalesce.getdbt.com. I'm learning a lot as I'm listening to you talk about this. I've read a ton of stuff that your team has produced, and you and I have spoken about this before, but I'm still learning a lot right now. Can I serve you up maybe a softball? I really don't know what you're going to say to this, but I bet you have a good answer. If there are data warehouses today that are starting to do things like, BigQuery has its BI engine, and Snowflake has I forget what it's called, like search optimization service or something like that, where you can like turn it on for a table. And my understanding is that essentially like both of these services kind of like keep the table in memory so that there's not an extra read step. Do you think that it is possible that the end result is actually that making queries faster is like a thing that the existing platforms can turn on? My guess is you're going to say no, because it sounds like what you've done is actually a much more integrated approach to like navigating the trade-offs of database design. But I just want to hear you say, well, like maybe a little more about that. Actually, I'm glad they're doing it, because Tableau dashboards are too slow in the world. Like, please build BI engines, solve the problem. There are actually customers that also use Rockset for that. It's not our primary use case, but people have, moved, dashboards from Snowflake and other data warehouses, and it has gotten 100x faster because of the indexing tech in Rockset. Queries that used to take 2 to 5 seconds run in 18 milliseconds in Rockset.
So the indexing tech is valuable even when the data is not real time, which is funny. But your question was different, which is like, why can't people just accelerate queries with just like in-memory engines on the other side? Well, there are only two hard problems in computer science. One is naming, the other one is cache invalidation, right? What happens to the BI engine when there's new data on your underlying table? What happens if that underlying table is changing every second? So if you want to continue to do batch analytics and you just want a painkiller, like a steroid, or that is not sustainable really, well, it's still better. I mean, pain, so like give me something that I can limp along. But it doesn't really make you better, right? It's not like, it's almost like a crutch that you absolutely need to relieve pain in your organization. Because again, warehouses are not really built for sub-second analytics. So you have to do all these unnatural things. The real question to ask is not, why are they building a BI engine and not secondary indexing, right?
I actually had that, so why?
Exactly. Very good. That's the real thing. Because if I'm a database guy and I want my queries to be slow, what do? I want to build an index. Why can't warehouses support this? Because they are storage optimized. So the real reason is warehouses assume the data is immutable. This is not a simple assumption in like one part of the code base. The entire architecture is built assuming I can column compress the data very, very highly. And the whole architecture is about, I'm going to be spending on huge volumes of data. And these systems and algorithms were invented in the early 2000s when storage was much more expensive. Storage is actually not that expensive these days, right? A terabyte costs $25 in the cloud a month. So that was not the case. A terabyte hard drive, you couldn't even buy it for like $20, back in early 2000 when C-Store and all these databases were invented, because they had a problem of how do I build a database that can store massive amounts of data very, very efficiently. This is the genesis of all warehouses and data lakes in the world, because that is what I'm spending 24/7, even in the cloud. And so they compress. And one of the assumptions that it's very easy to compress data very efficiently is I'll never do updates. Because if you compress the data and there's all these algorithms that allow you good compression, but once you update, you really can't take advantage of like a lot of the compression techniques. So that's really why. Because even if you have a table, and let's say you only do append on a table and you have a secondary index, but every time you insert a new row, you're actually updating the index. And data warehouses just cannot be very, very good at mutations. You go ask anybody that has tried to use a data warehouse and they have an absurd workload, go talk to anyone. They would have a lot of scars to show you on how difficult it is to work with a lake or a warehouse when you have an absurd workload where you're not just inserting, but you also have to update once in a while existing records. You have to jump through so many hoops. Again, all of that comes from the rigidity that warehouses have. Well, they do have a hard problem, right? If people do have hundreds of petabytes of data, you definitely need very storage optimized systems for that. I think the only thing that we are saying is, yes, you do need a warehouse and a lake for hundreds of petabytes of data, but don't build your applications on there. Don't do anything. If you have a lake or a warehouse and you're spinning compute 24/7 on it, you're doing it wrong. Don't complain your warehouse or your lake is expensive. You're doing it wrong. You can't be spinning your compute 24/7 on a lake or a warehouse, spending maybe 4x more than what you should be spending, and your application is at least 10 to 100x slower than what it should be. So there is always a need for storage optimized systems that are still queryable, on which you can still do analytics. And that's batch analytics, periodic reports over large volumes of data. But when you come into real-time world, it's not just about, real-time analytics, it's also applications. And so both queries and data will never stop coming, and they need to be compute optimized.
Julia, we've talked a lot about databases are foundational infrastructure. And to a certain extent, you can't fully use the database until there are applications that are developed to make full use of this new paradigm. I feel like people have talked about data products everybody has their own take on data products. Like, what does that mean? What will a data product look like? To a certain extent, people are making data apps or data products today, but do you have a view on like where that space is going to go over the next 5 years? Like, what are people going to build with the stuff that Venkat is making?
Yeah, I love it. I think when you said earlier, Venkat, about how people want faster horses, not automobiles, that's exactly right. Like, people are too constrained in what the limitations might be. So people's mind go directly to dashboards, but that's not what the goal is. Instead, we can take action on these data and insights. So if you feel like you have the right insight at the time, you can build apps to make decisions on behalf of the company as well, not just report out. So I think there'll be a lot of more than just news feeds, but I think there are a lot of healthcare applications where you absolutely have to make smart decisions real time based on maybe patient health. things that are really mission critical, perhaps in the logistics space where, yeah, wouldn't it be great if we could know that your airline was going to be delayed and bring you a better plane and make that journey a lot smoother? So I think real-time decisions that will be built off of data that comes in real time is just a matter of time. But it's still a lot of work to get people to think about the realm of possibility and move them towards that future.
I'm excited about all of that, but allowing analytics engineers to build data products and not necessarily requiring full-on senior software engineers to create every single data product that exists.
We are a big believer in that too. Like, if you know SQL, you should be able to build a data API. So one thing that we're very proud of that we created, and I think other vendors are copying us now, is called query lambdas. So what Rockset allows you is, if you're on the data team, if you're on, and you want to provide a cleaned up version of data to one of your consumers, a lot of the time you do ETL and you have these tables and you only expose, okay, here are the tables that you can go now, do whatever you want to do with, except that a lot of people might not use it efficiently. Instead of exposing it as tables, what Rockset allows you to do is to convert a parameterized SQL query, give it a name and expose it as a REST API. And so you can come into Rockset, get all of your data in as fully indexed tables, construct a complex query with parameters and what have you, with a single click of a button that can be exposed as a REST API endpoint, which are called query lambdas. And that I think is great because a data API is like the MVP for a data product, if you think about it. I have an API, it's just a REST API, and we want like eventually to do GraphQL and other integrations. But I think we definitely think very similarly, which is APIs are much easier to manage and easier for people to iterate on and improve upon than giving tables and say, you go figure out the SQL, and some are going to be slow and some are going to be fast.
I hate to admit this, but my biggest takeaway is that RocksDB is responsible for my constant refresh of my newsfeed and that addiction I have to always wanting more content, and it just keeps getting served. But we ask all of our guests to answer this question as we wrap up. Looking 10 years out, what do you hope will be true for the data industry?
Entire organizations, like end-to-end, the analytics stacks becomes real time. And just like how people can't imagine Google search or Facebook newsfeed working on batch, they're like, what? That should be how every analytics inside the company should happen. Everything should be in real time, including complex ETL. And I'm thrilled to work with you all closely. It's kind of like really accelerating the future because it's going to come, whether Rockset exists or not. That is the future that I think is coming. I hope we can accelerate that, the timeline just a little bit by reducing the barriers for entry. So that's really where I think it'll basically be. We will be at a point where everybody takes real time for granted, not only for their own internal company analytics, but also on every SaaS product they use. If you go to a SaaS product or that provides anything, any automation within your company, whether it's marketing automation, sales automation, what have you, if it doesn't have embedded real-time analytics, like people wouldn't even use it. People wouldn't even buy it. So I think that's the world. Somebody said, I want to build an internal app. And they said, we have a bunch of Tableau dashboards and all that. And I want to make a web app because if it's slower than Instagram, nobody in my company uses it. So that was the words of a customer. And so I think that's where I think a lot of the SaaSification of enterprise apps and analytics going real time. I think all of that is what I think is in the future.
And Venkat, if users want to find out more about you, where should they go?
Rockset.com. We have a technical blog there. We share a lot about how Rockset is built, what are people doing about it. There's also a free trial, no credit card required for you to just kick the tires, and give us feedback. There is a live chat built into the product where you can give us feedback about what you like about the product, how we can make it better. We always want to continue to make the product better. You can also find me on LinkedIn and message me and tell me feedback about the product, feedback about this interview, anything that, I welcome all comments. Go check out Rockset. There's a lot of technical, content there that I think you'd really enjoy if you're interested in the space. One small announcement I want to share. By the time this podcast comes out, I think we would have announced our DBT Rockset adapter.
Oh,
yes. We've been working on this and it's at a point where it's functional. So we want to open it up. It will still be beta. It's not ready for production use yet, but I can't wait for, the DBT community to check out the DBT Rockset adapter. It'll support all the way from bringing data from external sources into Rockset, automate collection creation, view creation, aliases and query lambdas and everything. So please follow the space, and we'll love to hear feedback about the dbt Rockset adapter 2 and what's working and what feature requests you would like.
That's amazing.
So yeah, so very, very happy to share that.
Thanks so much for joining us. I've learned so much today, and I really appreciate your time.
That's awesome. Thank you.
The Analytics Engineering Podcast is sponsored by dbt Labs and is hosted by Tristan Handy and myself, Julia Schottenstein. Have comments, questions, or guest suggestions? Email us at podcast@dbtlabs.com. Our producers are Jeff Fox and David Krevitt. If you enjoy the show, please drop a review or share it with a friend. Thanks for listening.